It's recording. Okay. Basically, we're going to cover a lot of stuff to do with functional JavaScript. My first question for you guys is, what does it mean to you that JavaScript is a functional language? Raphael?
It treats functions like first-class citizens, I guess.
It does. So what does that mean? What can you do with functions in JavaScript? There's 4 things you could do with functions.
You can set scopes inside of functions.
You could. I mean, a function comes with its own scope.
So it's local scope.
Yes, and you can put more functions inside it. What is it called when you put more functions inside of functions? Yes, you can return functions from functions.
Higher order functions.
Yes, higher order functions. So that's one weird thing that you can do with JavaScript. You can have a function return a function. What else makes functions so special in JavaScript? Ka?
You can save it to a variable.
Exactly, you could save functions to a variable. That's 2 things. Let's put those down. So functions can return functions. Can save function to variable. Does anyone know what the other 2 weird things are that you could do with functions? Raphael?
Can a function take another function as an argument?
You can, exactly. Take another function as argument.
So as a variable, if you set it to a variable, right?
Yes, or not necessarily even.
So like
Things like .map with an anonymous function.
Like a
Takes,
callback.
exactly, callbacks. That's exactly what this is. What other weird things can functions do?
You can make them into one line.
You can. I mean, yeah, that is true. All right, so does this mean anything to anyone?
Yeah, that's what I meant.
That's not an iffy. Being able to write a function in one.
Invoked function expression.
Exactly. So what does that mean?
You can send it to one line and then immediately invoke it.
Okay, but setting a function to one line is a different concept from immediately invoking it. Miles?
You can use the invocation operator to like tell when you want, like you could reference a function without it invoking.
Yes, that is the opposite of an iffy. That is a callback when you reference a function without invoking. An iffy,
So
Raphael.
it's basically a function that just basically it fires up without you having to call it. It just
Yes.
automatically starts.
Yes, as you're declaring a function, you can actually wrap the whole thing in parentheses and then put your double parentheses to invoke it, which we'll get into an example of doing that. And as for saving as variables, another thing you can do is save functions inside of an object. This is kind of related. So this is like when it comes to key value pairs, you can actually have a key inside of an object that points to a function as its value. So these are like the cool things that you can do with functions. Raphael?
You use that like when you create like objects like classes.
Mhm.
They have like you can put like a method inside it, like a key, and then it
Mhm.
points to like arrow functions.
Yes, you could do that, exactly. Stuff like that is really weird, but really cool. Does anyone know the difference between declarative and imperative programming? This is one of those things that you don't necessarily need to know the difference, but it's good to kind of see the different styles of programming that come in because JavaScript allows for both. And in case you get an interview question like this, it's a good piece of knowledge to have. And yes, the answer is there. Josh?
So JavaScript has the ability to do both.
Yes.
But there's certain languages that only do certain like declarative or imperative.
Mm-hmm.
Like
Does anyone know what languages do only one or the other?
I think I know one. The C is imperative.
Probably. I'm not super familiar with C. So, but let's get back to the difference. So what's the difference between imperative versus declarative? Gerald?
It's in there.
I know, which is why I'm asking.
Declarative, you declare variables which will think out functions as something else, and then imperative, you say
Okay.
like make you force it.
Kind of. So with imperative, it's when you tell your program step by step how to do something. You force it, I guess, to do it in a specific way. You tell it first make this for loop here, iterate through this thing, do an if check, if this, do this, otherwise do something else. You're telling it step by step how to run the code. We do that with Ruby a lot. With declarative, you basically tell your program what you want. I want this result. Bring it to me. And you don't necessarily care how it's done behind the hood. And you can do this in JavaScript.
Really?
So an example, yes, I have some links up here. This is an article you guys can look at. Is this imperative or declarative?
Imperative.
It is imperative because you're telling your program step by step how to do this. You're going through a for loop, returning this thing. Declarative looks something like this, where you just declare, I want to reduce this array. And in one line, you're able to like declare what you want and get it back. And there's actually some languages that we worked with that are declarative. Does anyone know what they are? I wouldn't say Ruby. Something you might not think of so obviously.
Rails.
No, that's a framework.
SQL.
Yes, SQL.
Oh.
Because when you're communicating to your database, you're just saying like, I want this row. You're not telling it how to find that particular row. You're just saying, I want the row where ID is 5 or whatever. There's another one.
Python.
No. Something we do here. We don't do Python here. Something that helps you with styling. CSS. Because you say like, I want my background to be red. That's like a very declarative language. So that's just something to be aware of. What about pure functions? What is pure functions? Miles?
They're functions that, like, given the same input, will return the same output. So they're like
Yes.
reliable and consistent in what they return.
Yes.
And they also don't have any side effects.
Exactly. Yeah, so there's a few things that you need to know about pure functions. And this is going to help you. Calm down. This is going to help you going into React. You're going to realize that purity is desirable in JavaScript, especially going into React. You don't want to be mutating things as you work with them. So some things to do with pure functions. When you have the same input, you get the same output, as Miles said. Also, no side effects. So what does it mean for a program to have side effects? What do we want to avoid doing when we make pure functions?
I guess the function shouldn't affect other parts of the program. Like,
Yes.
Or maybe do like Ajax calls or anything like that.
Yes. So we don't want to affect other parts of the program. We also want to avoid sharing state. So we don't want functions to rely on the same global variable or something like that, because then it'll be mutating that. We want it to stay self-contained, right? You get the same input, you get the same output every single time, and it's just like a self-contained little function that doesn't affect other parts of your program. Even things like console log are considered side effects. All right, so let's actually have an example of an impure function, and then we can make it into a pure function. So I'm going to make an array. And then I'm going to write a function called doubler that is going to take in an array and double everything in that array and give it back to me. So something like this. All right, let's test it out. So it looks like it's working. But is this a pure function or an impure function? Impure. Look what happens. The input is no longer reliable. We're not getting the same thing out as we put in anymore. So how do we fix this so that it's a pure function? So every time I pass it this array, it gives me the first result every single time.
We'll go back to the code.
What's making this function impure?
Because you're returning the array up there, but you can't
I'm going to tell you what line of code it is, but you tell me why. Will?
It's mutating the original.
Yes, it's mutating the original array. So, what are some things we can do to avoid? Raphael?
You can use a spread operator to just make
I
a
love
clone of the original and then
Yes.
just operate on the copy.
I love the spread operator. That is one thing you could do. So we can do something like const copy, make a copy of it. So how does the spread operator work?
We dot dot and the name of whatever you copy it.
Just like this?
Then you have to put it it's not supposed to be curly braces.
In these things. So the spread operator spreads out all of the arguments in your array as if they're no longer in an array. And then the brackets puts it back like into a fresh array. So this way you can make a copy, right? Let's test a few things out here. I like using node. So let's say we have an array of students. We have Raphael, we have Ka, we have Will. Who else wants to be in my array? Gerald. Jerbear. Right, so we have this array. If we make a copy, can we do this?
copy.
Can we do this? We can? All right. What's the problem with doing this?
Copy is the same array.
Yes, so it actually points to the same array in memory. So if I push something into array, say I push Kudzanai. Oh no. So now copy actually also has this, so that's a problem. So we don't want to do that. So if we make a copy, I'm just going to reassign copy to the spread out version of this array. Now they're pointing to two separate things. So if you actually do copy triple equals array, you'll see that it's false, which is a good sign. Now they're completely two different objects. So they would actually point to the same thing if you did something like copy
Wait, can you
2.
do copy is equal to double is equal to array?
Let's do that. Yeah, that's exactly what it's going to do. So now copy 2. If you do this, they're actually pointing to the same thing, right? So the spread operator lets you make a copy, and it's like they're pointing to two completely separate arrays. The other cool thing about the spread operator is you can actually add other stuff to it too. So if I put my array of students, say I wanted to put some other students too, like Jeff. Who else do we have? Josh.
Jonathan.
All right, all the J's.
That's it.
So we can do that. We can even put stuff in the beginning if we wanted to. So say we put Jane
Giles.
and Matt. This is pretty cool, guys. So I have my ... array in the middle, and that represents all of these items. And now they're spread out so they don't have brackets around them. And then I put all these other items around them. And look what happens.
Nice.
This one stays intact here. And those other ones that we included afterward are appearing afterward, as well as the ones beforehand. So you can do cool stuff with it. Yeah?
Can you also
clone an object
Yes.
with this spread operator?
Yes, we'll get into that as well. So this is how you can clone. And then if we change this to copy, now we can actually see it's always working with a fresh array. And this is now a pure function. There's another way that you can clone something. Does anyone know? Ka.
Slice.
Yes. How did you know? So what does slice do? Yes.
It just, slice takes a piece from the array, but I guess if you don't give an argument, it would just give you back the whole array.
Yes, slice is so cool. There's so many different ways to use slice. You can use it on strings and you can use it on an array. And it can take one argument, no arguments, or two arguments. So basically you tell it where to slice from, and then it can go until the end if you give it just one argument. So if you do something like this, it would slice from the first index, so like 2 onward. If you give it another argument, it's going to slice up to that index. So this would slice from index 1, and then it'll also print out 2, but not the third index. So that's like all kinds of stuff you can do. You can even do something like -1. And this will only print out the last value. Or you can do something like 1 to -1. And it's going to go from here and exclude the last value. So another thing that slice does is if you don't give it any arguments, it just copies the array. So that's another way to do it. Any other ways?
There's one, you can use it with this one, object.assign.
You can do object.assign with arrays as well. I'm much better at that with actual objects. But I think it would take an empty array and assign this array into an empty array. Let's see if it works. Yeah. And of course, if we wanted to, we could just make our own array. So let new array, something like that. And as we're iterating through, instead of reassigning something, we can just push the result into that array and do something like that, right? So like new array dot push. So that would also work, right? So these are some ways that you can avoid mutating an array. And so now let's talk about avoiding mutating an object or copying an object. Any ideas?
Okay, so spread won't be on the code challenge.
You need to not obsess so much about the code challenge because you can actually use spread wherever you want. You can use it on the code challenge if you like, as long as you understand the use cases of it. It's also super useful in Mod 4 in React because there's going to be times where you're dealing with something called state and it's going to look like an object and we can't mutate that state. So we need to use kind of like a new state. So for instance, say I have an object and it's called Matt because he's not here so we can talk about him. So his occupation is TCF. What's his personality in one word?
Loud.
Loud? I heard friendly too, so I'll put that one too. All right, so if we wanted to copy Matt, how would we do that without mutating Matt? Because right now, if I just did something like let copy equals Matt, they're just going to point to the same place in reference. So to show you that, this is copy. This returns true. We don't want this behavior. What do we need to do? Raf?
So can you use the spread operator again?
You can. So how would you do that in this
So
case?
this will be curly braces.
Yes,
And then dot, and then the name.
exactly. So the spread operator lets you spread apart all of these values, and then you put the curly braces back around it to turn it into an object. You can also actually add other stuff if you wanted to. So if I wanted to add any features into my new mat object, I could do that as well. So what do we want to add in here? Or even overwrite? Spirit animal. What do we want his spirit animal to be? All right. And then say we wanted to override his occupation. Say he becomes a lead instructor. So you can do stuff like this, right? Because it's just an object. So you have all of these properties, and these will be new ones you want to add, and these will be things you want to overwrite. So let's see if that works. So now I have this brand new object. And if I didn't have this stuff, you can also see that copy doesn't equal mat. What about object.assign? How do you do this with object.assign? Raphael?
So be object.assign, and you add the first argument would be an empty object, and then the next one would be mat.
Yes. So object.assign takes a few arguments. The first one represents where you want to put all of these properties from mat. And we want to use a clean slate. So we just want to put all this mat properties into an empty object, right? If we wanted to, we actually could put another object here. And all of these properties would get merged into that object. But the better practice is to use this empty object as a fresh slate. And then the second argument is mat. So all of the properties that we're trying to copy over. We could actually add more arguments if we wanted to. So we could actually put other stuff we wanted to add, like this. And that would copy all of these other properties into it too, and it would either overwrite or add new properties. So let's see that one. Copy. And there we go. So that's another way that you can do it. All right, cool. So we covered all this stuff. Just be aware that using stuff like the spread operator only makes shallow copies. So that means if you actually had a deeply nested object, like for instance, you had an array value or another object, and you did something like the spread operator or object.assign, the deeply nested thing would still get affected. So say Matt likes some food, right? Say he likes pizza. What else does he like?
Mulberry vine.
Mulberry and vine? Mall and vine? All right, so say he likes this food stuff. And we made a copy of Matt by just doing copy. So the problem here is that our copy.food is actually going to be the same as mat.food. So copy.food is this array. Mat.food is this array. So they're still pointing to the same thing. So that's a small problem that you may or may not run into. If you run into this problem, there's a good Stack Overflow answer that I found for it. What is the most efficient way to deep clone an object? And you can look into that, and you can use stuff like JSON parse, JSON stringify. So you basically turn it into a string, and then you parse it back into an object, stuff like that. Yeah, you're not going to really run into it that often, but it's just something to be aware of.
Could you just make it another copy?
I think you could also keep using spread operator
Yeah.
to spread that as well. So I think you could overwrite mat.food if we wanted to. Or we would give it a new food property and overwrite it. I think you could do that too. Let's see if it works. Yeah, so that works as well. So keep these things in mind for React. Yes,
So
Gerald.
how do you use JSON that parse and JSON that stringify?
So let's try it out. If you wanted to make a deeply cloned copy, this part will turn the object into a string, and this part will parse it back into an object. So you would just do that. And then, if we test it out, they're also pointing to separate things. So just a few ways to solve this problem. Okay. So higher order functions. What are higher order functions? Raphael?
For functions that return another function or that take a function. as
Mhm.
one.
So return other functions. Anything else? Anything else that higher order functions can do? They can also invoke other functions. So JavaScript is really cool because you can actually write something like this, where you have a function that just calls other functions. So I can have something like function runner, and I can give it an array of functions. And then I can iterate through this array of functions and invoke all of them. So I can do something like, maybe I'll put my results in an array, and then I can do like, so how do I invoke one of these things? Yes, but there's more to it than that. What would I need to put here?
Return.
Well, we're putting it into the results. We're putting it into results. But how do I access an element in this array? Yeah. Yeah, so that looks really weird. It's really weird because it's actually a function, and with functions we can invoke it. So you can actually do stuff like this in JavaScript. And then we can return the results. So if I were to have like a function called hello that returns hello, and I had a function like world that returns world, I can actually call function runner. Let's see what happens. This is really powerful stuff. This is what makes JavaScript so powerful. Because in Ruby, we learned things kind of rely on classes. But in JavaScript, all the communication happens with functions. In fact, there's actually not real classes in JavaScript. There's a class keyword in JavaScript, but it's just syntactical sugar for writing yeah, it's fake. And my theory is that it was written just for people coming from other object-oriented programming, like from Ruby, things like that, who are used to the class keyword, so it's kind of easier for them to work with JavaScript. Gerald?
So div.class would equal like whatever class it is inside div, or is it div.class name?
So that's a DOM element. That's not really related to this. I'm talking about stuff like this. So we haven't gotten to classes yet in JavaScript. But do you remember in Ruby writing a class and then you have self? You have stuff like that?
Yeah.
In JavaScript, in order to write a class,
Yes.
you would write something like this. You use the this keyword instead of self, and you actually write a function in order to write a class. It's just with the newer syntax, it's now this. So you can use the keyword class. But it's important to understand that classes in JavaScript are not actually classes, they're actually functions. Josh?
So is that why it's kind of like fake-ish? You know, it's a way to help organize? Because I've seen the class be used, but like in separate JavaScript files. So is that just to show you that this is the one that I'm using? I'm having the JavaScript on, like, that I'm using to implement JavaScript on that class.
For class-oriented JavaScript? To do DOM stuff?
I would have to show you, like, when I'll show you later.
Yeah, I'll have to look at that later.
Yeah.
Okay, so let's talk about closure. And that will be the last thing we talk about. Miles has just left, unfortunately. Do you guys want a short break?
He came, he just went out. He left the computer.
Do you guys want a short break? Or do you want to just dive into closure? It's probably going to take maybe half an hour to talk about it, maybe less. All right, let's talk about closure. So closure is a common interview question that you often get in JavaScript. And in order to approach this closure topic, we have to understand how the scope chain works in JavaScript. So if you actually Google closure, like what is closure in JavaScript? You get something like this. Closure is a feature in JavaScript where an inner function has access to the outer enclosing functions variables. Scope chain. The closure has 3 scope chains. It has access to its own scope, variables defined between its curly brackets. It also has access to the outer functions variables, and also has access to global scope. So let's deconstruct this a little bit so that we can understand closure. So, say you have a function. What do we want in the inner function? Say we have a variable here. It's set to the string bananas. Say here we have a var bananas. What should we set it to? It's going to be something different. Potato. All right. Say we return a function. Example 2. Say this function has its own bananas. What should we set it to?
Tomato.
Tomato? Do people actually say that?
No.
Alright, so this function needs to return something. Right? Because functions need to return something in JavaScript. The question is, if I were to console log bananas here, what would I get?
Wait,
What would
console log
the string-
Console log where?
If I console log it here,
Tomato. Tomato.
yeah.
Tomato. Tomato.
So the thing about this plays into closure is understanding what variables you have access to. If you're inside this very inner function, this very intimate function here, you have access to these bananas and these bananas and these bananas, right? Especially if they're named different things, you have access to all of them. If they're all named the same thing, when I hit like console log bananas, my program is going to look up the scope chain, and the first bananas it finds is going to be the one that it prints. So here, there's one in its own local scope. So if it finds these bananas, it's going to print tomato.
So if you did let in all of them, would it not be tomato?
I don't think that will have an effect.
What if it
We
was
can
const?
play. I don't think that will have an effect. We can play with it though. You want to try?
No.
No? Okay. But like if we named this something different, like if this was banana, and we console logged banana, then it doesn't have a banana in this local scope, so it's going to keep going up the scope chain. This is its next level of scope. So it's going to find banana, it's going to print potato. Right? So it's going to keep going up the scope chain. So that kind of comes into play. And that's what it means by the 3 different scopes. That's its own scope, the inner one here. Then its outer scope, which is the function that surrounds it. And then as well as the global scope, which is the highest level scope that it has access to. So, in order to demonstrate closure, we're going to first do an example that's not really a closure, and then we're going to refactor it to make it better. So for this one, we're going to actually use a global variable for now, and then we're going to change it. So say we have a counter like this, and then we have a function called apples. Doesn't take any arguments, but it increments this counter. And say we're like selling these apples, and it's going to return how many apples we've sold. So what happens when I try to see what apples is? What is this going to be? Wait.
Wait, can you go back?
Yeah, let me actually have them side by side.
What happened?
What am I going to see when I just type apples?
I sold 1 apple.
I've sold 0 apples.
Say that louder, Will.
You'll see the function.
I will see the function. So this is getting you guys used to the idea that you can have these freestanding, uninvoked functions. You can pass around functions in JavaScript. You can save them to a variable like we did here. So we have this function. Okay. And then when I invoke it, what happens?
I sold 1 apple.
Cool. Now I'm selling apples, right? I'm selling different kinds of apples. What if I want to do this for pears? Let's see what happens.
One.
2, 3. And apples? What's going to happen?
4 apples.
Yeah. That's not really good. That's not really the behavior that we want. So how do we change this in order to avoid? How do we use closure? Let's get some exposure to closure. That's one of my favorite jokes. Gerald?
Create a higher function.
Yes. So
So function count.
yes. So you want to, let's just do
no,
it in here.
above. Isn't it above the 51?
It doesn't matter too much. We could do it above. But I think it would be easier to do it here, less refactoring. So what do you want to put in here?
Count.
Okay.
Like count equal.
You want to put this one where? Here?
Yeah.
And what do I want to do with this one?
Keep it there.
Keep it here? Shall we test it out? Let's think about scope before we test it out.
Okay. So return, put it up there. By 55.
Put it
Switch
here?
over- switch- yeah.
Why?
Because it can't access the count
Yes, exactly.
outside.
Exactly. All right. Let's see what happens. How do we invoke this? How do we get it to work?
Apple.
Double parentheses.
Oh, yeah.
What is apples?
It's a function.
It's a function. What is apples invoked?
It's the return function.
Yeah, it's whatever the value is that goes after the return, okay? So how do we get this innermost return statement?
Another person from the site purpose. Yes.
Uh-oh. Oh no, that doesn't seem to work. Why doesn't this work? Ka?
Because it's resetting
Yes.
count was in that.
Exactly. Yeah, Because every single time, we're just invoking it twice. And every single time, the first invocation starts this at 0, we add. And then the second pair of parentheses just returns this.
So put that count under apples.
So here?
Yeah.
Okay. Ah, yeah. Okay. On the right track. So, the thing about closure, in order to create a closure, we need to invoke this outermost function once. And when we invoke it once, that's where we initialize this counter to 0. And then we need to have the ability to invoke this inner function multiple times. So how can we accomplish invoking the outer function just once, and then being able to play with the inner function multiple times? Let's try it with an iffy. So how do we do it with an iffy? I was gonna use that joke. I find this whole iffy business a little iffy. But let's do it with an iffy first. So what is an iffy?
You like puns, don't you?
Huh?
You like puns, don't you?
I do. Dum dum dum. So it's an immediately invoked function, which means as I'm defining it, like I am here, I can invoke it right away. So how do I do that in this case? Well,
You would want to wrap it in parentheses and then
okay. So where do I start the wrapping?
I'm actually confused. Okay, well, before the word function,
So here,
yeah,
and then?
and then we stop the whole inner function and then invoke it.
Okay.
That's wrong, right?
That's an interesting guess, but let's see what happens. Oh. Yeah. So right now we're just immediately invoking the result as if we didn't even have this inner function. As if we were just doing count plus plus, return, whatever. Raphael?
Would be after apples equals, then you'd be open a parenthesis there, just basically you close overlap.
Yes. Yes. Because the key is to invoke the outer function once. So now, this is closure. This whole outer function gets invoked once, and the inner function can be invoked multiple times after that. Because now, this apples variable is no longer equal to this function. It's actually equal to this part. Or actually this part. Let's see what happens. So what is apples?
The whole function.
Which function is apples?
The outside function.
Not anymore. What is apples? Why is it this?
Because the function apples returns the function definition.
Exactly.
You're immediately invoking it.
Exactly. We're just getting what it's returning because we're invoking this outer function. So now apples is no longer equal to this whole big function. It's just open, or it's just equal to this inner function, which means the big outer function has already run once. So count is currently at 0. What is apples invoked going to be? What is this going to be? A string, and what is that string going to say?
So, 1 apple,
And if I invoke it again?
2 apples.
Yes. So this is closure. This is how we create a closure. I can do the same thing with pairs if I wanted to. So our apples are going to be separate from our pairs, right? But I find this iffy business kind of iffy. So let's ignore pairs for now. Is there any way that we can achieve this same behavior without using an iffy? Miles?
We just invoke the function twice.
So, like this? So we're back to the same issue. Because every time we're just starting over. Yes.
You stepped in right.
Yeah, I understand. It's okay. So, we can use a variable. How can we use a variable to help us? Raphael is thinking. Talk to me, Raphael.
Processing.
Wait. Can you return function? Can you assign that to a variable?
You can. So,
Maybe you could just either return the variable or return the variable with evokes parentheses.
so what am I setting this to? We want it to be this thing, right?
Yeah.
So how do I get that thing? Running what code produces this result?
Apples?
Apples, just like that?
No,
Apples invoked. Yes. So now this code will run once, right? And now I can invoke apple seller. And this is that whole thing where variables can hold functions. So now this apple seller variable is actually this whole function. And I can invoke that function as many times as I want. So let's see what happens. So what is apples? What is apples? It's not the inner function. Apples is the whole thing. We're not doing anything to apples. Apples is the whole thing. What is apple seller?
the return function.
Yes. Now it's the inner function because we've ran apples invoked. So we invoked this function once. We started our counter at 0. Right? So now apple seller, we can keep invoking. And it's going to keep going up. And we can do the same thing with pairs if we wanted to. But what if we wanted this to work for any fruit? How can we generalize this? How can we make this into a fruit stand that takes in a fruit? Yes. And then what?
Apples to string with different fruits.
Okay.
And then it has that.
Fruits? Okay. All right, let's try it out. What kind of fruits do we want to sell today?
Pineapple.
What do I have to set it to? Mm-hmm.
Fruit.
fruits do we want to sell today? It has a lot of different spelling for lychee.
So it's Lychee.
Everyone has different spelling.
Lychee.
Fine. What else? Get a little more exotic. Orange, fine.
Oh, okay, fine.
Oh.
Durian? Is that the stinky
Oh
one?
my god.
It's Gerald's favorite fruit.
No.
Alright. This is enough examples. So,
Passion fruit.
no more fruits. Okay, so now pineapple. I'm selling pineapples at my fruit stand, yo. Check it out. Lychee. Different closure. Selling lychee. Not affecting my pineapples. Selling oranges. Also different closure. Not affecting all my other fruits. If I go back to pineapple, it just picks up where it left off. This is closure. Alright, you can clap.
I'll let you.
That's all. That's all for this. I mean, if you want, we can go over async await.
Yes, go over async await.
This was fun. I really like closure. Once you get it, it's really cool. But it's also, there's not a lot of use cases for it. So if we want to go over async await, let's see. I have that review that I did last time.
This is the big panel.
Okay, so
This the whole time.
guys. Async await is pretty easy. It's just a different way to write promises. So instead of writing stuff like fetch, what does fetch return?
A promise.
Fetch returns a promise, right? What do you have to do afterward?
You have to parse the promise.
What does that even mean? How do you parse a promise? Hi, Travis.
.NET res.
Exactly. So the problem with promises, when you have something like this, like a fetch that returns a promise, you never get the actual value out of that promise. The only thing you can do is you can put a .then afterward, and your .then takes a callback. And that callback takes in whatever the value is that finally comes out of that promise when it's a real value. And then you can indicate what to do with it. And then that returns another promise. So then you got to chain your .thens and all that. So the problem that async await tries to solve is this whole promise chain and never being able to touch the result of your promise and interact with it, except for chaining .thens after it. So, say we have something like this. Say we have our fetch animals. The only thing you need to know to make async await work is you got to put an async in front of a function where you're going to try to use this functionality. And then, this is the moment of magic. Say you have like let res, then you can put this promise here. And you can say await this promise. And now, this is an actual real thing that I can interact with. So if I console log my res, I'm going to take these out or else things are going to break. Let's see. Okay. Where are you, animals?
This in the code.
See, I got an actual response. Right? Oh, here it is. I have an actual response object. If I wanted to parse that response, I can be like await res.json. So it's just a different way to write promises. So you can interact with the results of those promises without having to chain .thens. So now, oh, haha. I have my animals. I can console log them as if they're not even a promise anymore. So what async does is it makes this whole function asynchronous. But it makes everything in that function run in order. So this can be pretty powerful. Miles?
Can you then like return the animal?
Yes, you can.
And say,
Yes, that's why it's so cool. And if you wanted to, maybe in the beginning of your program, you can put an async in front of your DOM content loaded. And maybe if you wanted to have access to your animals right away, you can be like const animals equals this. And that returns a promise, because once you make a function async, that function will return a promise. But you can do something like this. Await this. As long as the surrounding function around this is an async function. So now I have access to these animals, and I can do all my other functionality without having to fetch them every time. And it can be pretty powerful. Isn't that cool?
Yes.
So no matter the method as well, like you can always use that.
Yeah, it can work with any promise. So, Miles, more questions?
Yeah.
Yeah.
Is this legal syntax on the code?
Yes, it is legal syntax on the code challenge. In fact, my first group of students, Octothorpes, they were having a little bit of trouble with like promises. They were like, but how do I console log the thing that the promise returns? And I was like, you can't do that. The only way that you can do it is using async await. So they all went out and learned async await. And then after the code challenge, I think I was like out that day, but I checked in with the lead instructor, who was someone else at the time. And she was like, you know, they all did great, but they were all using async await, and I didn't teach them that. And I was like, I didn't teach them either. They just went out and they learned. But yeah, you can do this for anything. You can do it for these fetches. You can even mix them up if you really wanted to, because this whole thing returns a promise, right? So if you really wanted to, you can be like return await this. And then it'll go all the way down to here, to this animal. And it would return the result of this. You see? Except you start going down the rabbit hole of having to put async in front of every single function, and then you're creating more asynchronicity. But that's kind of how you work with async await. Any questions? Benson?
So, like, in terms of like the promises, it doesn't have to be a get, right?
It can be any promise.
Anything inside of this restaurants can be any promise.
Yes. So there's even things other than just fetch that are promises. But it can be done with any fetch. And the .thens that are afterward are also promises. All right, anything else? Okay, that's it. Go home. Yeah, anytime. I hope you guys use async await because it's really cool. But make sure you do know how to use .thens as well.
Yeah.
We don't want it to be like, well, this way is easier and I'm only comfortable with this way. We want you to be able to do both ways.
If we ever saw someone